All right, so if you guys are ready, I am going to blow your mind literally with this lesson, with this unit. I'm going to shatter your world. All your assumptions about how you thought the world was on firm footing are going to be shaken by this lesson. And you'll be forever changed because I am going to introduce you to the idea of what's called an imaginary number. Okay, so before you think about, okay, wow, this is getting into like Alice in Wonderland kind of territory. We're talking about strange stuff. It is kind of strange, but just like anything else, when you first encounter a new idea, it's going to seem strange. But when you work with it, after a while, it's going to become a normal part of your everyday understanding. Okay, so kind of like when you first learned about negative numbers. So think back to elementary school when you first learning about your counting numbers. So a number represents how many things you can count. So 5, that represents I can count 5 fingers on my hand or 5 apples. But when you first learned about, think about when you first learned about the idea of a negative number. Now that's pretty crazy. What is negative 5? I don't understand that. How can you count negative 5 things? That doesn't make sense. But once you've worked with it for a while, now it's become just a natural part of your everyday understanding of numbers. Negative numbers are just the opposite side of the number line. They're like the opposite of a positive number. So it's nothing, no big deal, nothing new. Going to be the same thing with this. Up to this point, you haven't really had to deal with this new kind of number, but now that you guys are sophisticated and mature enough to tackle some pretty advanced things, I want to introduce you to imaginary numbers. Okay, so where does this all come from? Well, this goes back to the 1500s, 16th century. So talking about math in that era, that was when people were first learning how to solve quadratic equations and higher powered roots, quadratic equations at that point. And so inevitably, people came up with this equation right here, x squared plus 1 equals 0. Now, in order to solve this equation, it seems pretty straightforward. Well, this is you just subtract 1 from both sides and you square root. So obviously the answer is plus or minus the square root of negative 1. Okay, then we run into a big problem because of this guy right here, square root of negative 1. Okay, what in the heck is that? What's going on with that? Square root of negative 1? What number times itself will equal negative 1? Now, I understand regular square roots, like the square root of 4. That's 2 because 2 times 2 equals 4. Okay, could also be negative 2 because negative 2 times negative 2 is also 4. Okay, I understand that. I can understand the square root of a positive number. I can even understand something like the square root of 2. And that's not a whole number, but there is a number that when you times it by itself, it must give you 2. It's like 1.7 something. So I can understand that. But this is crazy. How do we take the square root of a negative number? That doesn't make sense. What times itself will equal negative 1? Okay, well, there's nothing. Negative 1 times negative 1 is positive 1. And the numbers have to be the same, so you can't say, oh, negative 1 times 1. Well, that doesn't work. A square root has to be the same number times itself. So up to this point, when you've encountered something like this, you've been told that, well, okay, the answer is no solution. So this equation, x squared plus 1, has no solution, we've said. Okay, and that's up to this point, that's been acceptable because we didn't want to take you into too much uncharted territory at that point. So until you learn about this new kind of number, yeah, it's acceptable to say, okay, we can't square root of a negative number, so there's no solution. But I want to get past this because this kind of equation, either this equation or some equations like it, are actually, believe it or not, really important for things like electronics, some wave mechanics, physics. So these equations actually appear quite often in real applications, believe it or not. So we need to be able to solve these. If we weren't able to solve these, there would be no such thing as modern circuitry. For example, when you design circuits, you're going to need to know what's the solution to this kind of equation. So there'd be no modern electronics, nothing that you take for granted. All of that would be null and void if we weren't able to solve this kind of equation. Okay, so we've got to get past this roadblock. We can't just say there's no solution because there actually is, but it's expressed in a new kind of number system called the imaginary number system. Okay, imaginary, you think, oh, somebody just made that up. It's just all in your head. Okay, well, we call it imaginary not because it's made up or it's not real, but because we needed a new term to describe it. And mathematicians often will use terms that have a different meaning in everyday speech. Okay, so even though imaginary in everyday speech means, oh, it has no basis in reality, it actually does. You just have we have a strange adjective that we use to describe it. Okay, so imaginary number. So to get us started, I'm going to make a basic definition. So I'm going to define a new number for you. You haven't really come across any new numbers recently. Probably the last kind of new number you had was pi. Okay, pi is this irrational number. Okay, but I'm going to introduce to you a new number. So here is our new number. Our new number is named I. And it's defined to be the square root of -1. Okay, so you think, well, what does that mean? Are you just kind of getting around it? Well, sort of. But often in math, what we do is we make a basic definition. And based off of that, we can build up a whole system of consistent math that works. Okay, so let's just take this as our starting point. Let's not think about for the moment. Don't think about, okay, what is this? If I punch this into my calculator, what am I going to get? What number times itself equals -1? Okay, let's not go down that road. Let's just take this as our starting point. Let's just use this as the first step, and let's see where this leads us, because it's going to lead us in some really interesting territory. Okay, so this is going to be our basic definition. I, this number I, called the imaginary unit. I, obviously for the word imaginary, I, small I, is our imaginary unit, and it's defined to be the square root of -1. Okay, again, don't think about what value it has. Don't try to think about, okay, what is this if I punch it on the calculator? Don't go down that road. Just take this as our starting point, and let's build up a whole system of algebra based off of this. We're going to see it's actually going to be consistent. It's actually going to be very beautiful in a lot of ways, and it's actually going to be very useful, believe it or not. Okay, so we can say, for example, that now we can say, for example, that the solution to this equation that we started with, this example, is going to be plus or minus I. Okay, so we can express the answers to these kinds of equations. Now, instead of saying no solution, we can express them in terms of this I, this imaginary unit. Okay, so here's a bit of advice. Now, when you first start learning about something new in math, especially something as crazy as this, these imaginary numbers, it's best not to try to think too philosophically deeply about it. Okay, don't try to think too philosophically about, okay, what is the value of this? If I get a value on my calculator, what's it going to be? Is it going to be 0.97612? You don't think along those lines. At first, focus on learning the rules for manipulating and doing basic computations with it. Okay, so focus on just the basic rules for doing arithmetic, addition, subtraction, multiplication, division. Just make sure you get those. What's going to happen is pretty soon, just like with negative numbers, it's going to become so routine for you that it's going to just integrate itself into your understanding. Okay, if you try to think too philosophically about it from the beginning, though, you're gonna tie yourself up in logical knots. Okay, so don't go down that road. First, focus on making sure you get the basic computational aspects of it down, so that they become routine and you can do them without thinking. And then you'll gradually notice that, okay, it just becomes a natural part of your understanding. Okay, once you get to the point where it kind of naturally integrates itself into your logic system, then you can start delving into kind of the more interesting aspects of it. Okay, how does this kind of interface with real numbers, graphing, all of that kind of stuff that you already know? Then that opens up a whole new vista of neat things that you can learn about in math. Okay, but for now, let's just focus on just the basic computational aspects. Okay, just the nitty-gritty of how do you do arithmetic and stuff with this. Okay, so our imaginary number, our friend I, which is the square root of -1. Now let's embark on kind of an investigation of how we do some basic arithmetic with this guy. What does it mean to add, subtract, multiply, divide?